Welcome back. In this video, we're going to think about conceptually using all of our rules to transform either a point, or on the next slide, we'll actually transform a picture of a graph. Here, we are given this point, -11, 6, which is on the parent graph. And we want to find the corresponding corresponding point on the transformed graph. So looking at what we're dealing with here, g of x equals -1/2 of f of x. So the 1/2, we're applying -1/2 to f of x, and the output we will get will be the transformed graph g of x. What does multiplying by -1/2 do? So multiplying by -1/2, well, think about the fact that f of x really means y, and also that this is multiplied on the outside. In that regard, that means our normal, our given xy ordered pair, is going to be transformed because we are going to multiply the y value by -1/2. You can see it is multiplied and it's on the outside of the grouping mechanism, or essentially just -1/2 times f of x, which is times y. So that means we take our xy ordered pair, -11 and 6, and we're going to take that 6 and multiply it by -1/2. So my answer for the transformed ordered pair is going to be -11. The x value doesn't change at all. And the y value, 6, multiplied by -1/2 is -3. So this would be the solution for that first transformation we're looking at in A. All right, let's look at example B. So the transformation g of x is provided by f of x minus 2. So that -2, it is added to the x, and it's on the inside of the grouping mechanism. So we know this is horizontal, it's going to affect x, and when things are horizontal, they're going to behave the opposite of the way we think. So whatever xy ordered pair we start with, again, in this case, -11, 6, we're going to take that x value and we will add 2 to it. Right, so we're going to do the opposite of what it looks like if it's on the inside. So that would be x plus 2, comma y, or -11 plus 2, comma -6, which gives us the ordered pair -9, -6. That would be our transformed point here. And for the last problem, g of x is given by the original function f of x plus 70. So again, if you think about the fact that f of x just means y, this reads as y plus 70. So we will be taking some xy ordered pair and we will be turning it into x comma y plus 70. So that would be -11, 6 plus 70, or -11, 76. So this third transformation would end up looking like this. Let's look at one more with maybe multiple transformations occurring simultaneously. In this example, we're given an ordered pair 4, -10, which is on the original function. And we are going to determine the transformed point by using g of x. So g of x is defined as being -1/2 times f of the quantity x plus 8 minus 3. So again, thinking about your transformations, -1/2 and -3 those numbers are occurring on the outside, which means they affect the y value. And x plus 8, that's occurring inside the parentheses, which means it affects x, and it does the opposite of what we expect. So if f of x, if we have some regular xy ordered pair, then on g of x, well, my x value, I would subtract 8. And then my y value, I would multiply y by negative 1/2 and then subtract 3. So this would give me my transformed ordered pair. So if I start with 4, negative 10, then what that will become is 4 minus 8 and negative 1/2 times negative 10 minus 3. 4 minus 8 is negative 4. Negative 1/2 times negative 10 is positive 5, and positive 5 take away 3 is 2. And here I have my new ordered pair. Now let's look at taking a graph and actually transforming that. In this example, we are again given f of x. F of x is defined as the function x cubed minus 3x squared, which we see graphed here. You'll notice on f of x, we have 1, 2, 3, 4 points which are labeled. What we want to do is to sketch the transformed graph. The transformed graph is g of x, which is provided by negative 1/2 f of x minus 3 plus 1. First of all, let's recognize we are given 4 ordered pairs, and because of the previous examples, we know how to take those ordered pairs and write them in their transformed form. So let's go ahead and list our xy ordered pairs. So my xy ordered pairs that are given are negative 1, negative 4, 0, 0, 2, negative 4, and 3, 0. Let's look at what the transformation would look like. The only number inside the parentheses attached to x is minus 3. So my x value will actually be x plus 3, remembering that we always do the opposite when we're applying something to the x values. And then y, these numbers on the outside, they're going to behave exactly as we would expect. So we're going to take this negative 1/2, we'll multiply it by f of x, or the y value, and then add 1. So my y will be formed by calculating negative 1/2 times y plus 1. Now, if I look at taking each of these ordered pairs and plugging them in, let's see what we get. So negative 1 plus 3 gives me 2. Negative 1/2 times negative 4 is positive 2 plus 1 gives us 3. My next ordered pair, 0 plus 3 is 3. Negative 1/2 times 0 is still 0, plus 1 gives us 1. All right, our third point, 2 plus 3 gives us 5. Negative 1/2 times negative 4 is positive 2, and positive 2 plus 1 gives us 3. And then lastly, we have 3 plus 3, that will give us 6. Negative 1/2 times 0 is 0 plus 1 gives us 1. So these 4 points, I applied that same transformation to each of those points to get my new 4 points. So I've taken my graph of f of x and I've sketched it on a larger graph over here to the right. So we see our original curve, this gray graph represents f of x. So let's plot our transformed points. So 2, 3, forward 2, up 3 takes us right here. Then we have 3, 1, so over 3, up 1. 5, 3, over 5, up 3. And 6, 1, over 6, up 1. Now, if we look at sketching these or sketching this curve, we're going to get a curve following the same order that looks roughly like this. So what you see is the graph has shifted right 3 units, it has shifted up 1 unit, and then it has reflected. Instead of going up, up, it now goes down, up, down. It's reflected over that y-axis. So I hope that helps you guys understand these transformations a little bit better. Please feel free to reach out or email with any comments, questions, or concerns. Have a great day.